Hey everyone, welcome to today's Explainer. Think of this as your ultimate cheat sheet to the future of work. We're going to take some pretty complex AI concepts and translate them into a clear, actionable path toward what we call true agentic coding. So, if you've ever wondered how we actually get from those basic chatbots to AI systems that act as independent, highly capable agents, you're in the exact right place.
Here's our roadmap for today. We're covering the language of AI, the 4 Ds of fluency, mastering prompt engineering, the 3 interaction modes, and we'll wrap up with Claude Code, agency, and action.
All right, let's jump right into Section 1, the language of AI. So, to really master AI, we have to stop treating it like just another search engine and start treating it as our new thinking partner. And to do that, we kind of need to understand how it actually thinks. Let's start with the foundation, the transformer architecture. This was a massive breakthrough in 2017 that literally changed everything. It allows large language models, or LLMs, to process sequences of text in parallel, all while paying close attention to the relationships between words across really long passages. You see, older models had to read sequentially, word by word. By the time they got to the end of a paragraph, they usually lost the context of the beginning. But parallel processing completely fixed that. It unlocked the ability to parse massive amounts of information without forgetting the earlier instructions.
Billions, literally billions. That is the scale we're talking about when we mention the parameters inside modern LLMs. Parameters are basically the underlying mathematical values in an AI model that dictate exactly how it processes language. When an AI reads your prompt, it's not just pulling up a pre-written answer from a database. No, it's actively running your text through billions of these interconnected parameters to figure out how different pieces of information relate to each other in real time. It's an incredibly intricate web of logic that lets the model synthesize completely new responses on the fly.
Now, how did these models actually learn? Well, there are 2 main phases, pre-training and fine-tuning. Pre-training is the phase where the AI learns patterns and foundational knowledge from vast amounts of text. Basically, this is how it gets its general worldly knowledge. Fine-tuning is the critical step that comes right after. This is where the model is specifically trained to safely and accurately follow your instructions. To put it simply, pre-training teaches the AI English and the laws of physics, while fine-tuning is what teaches it to write usable Python code or draft a professional email without, hallucinating or going totally off the rails.
Okay, this next concept is absolutely crucial. Temperature. It's essentially a dial for randomness. I absolutely love this analogy from our source material. Think of a higher temperature like boiling water bubbling away. It's highly varied, unpredictable, and super creative. On the flip side, a lower temperature is like ice crystals, highly structured, very predictable, and extremely focused. You adjust this dial based on what you actually need. If you want a wild, out-of-the-box brainstorm for a marketing campaign, turn the temperature up. But if you need a precise code fix that has to comply with strict syntax, you turn that temperature all the way down to freeze out any unpredictability.
Then we've got scaling laws. As AI models get larger, trained on more data, and use more computing power, their performance naturally improves in pretty consistent, predictable patterns. But here is the fascinating, honestly slightly eerie part. Entirely new capabilities can emerge at certain scale thresholds that developers never explicitly programmed. There's no way around it. Simply making the models bigger creates spontaneous capabilities. It is awe-inspiring to watch these systems evolve. It's almost like watching a complex organic system suddenly learn a new survival trick just as a byproduct of growing.
Moving right along to Section 2, the 4 Ds of fluency.
Let's shift gears for a second and transition from the machine's capabilities to our own human behavioral skills. I really want to slow the pace down here because we have to focus on how we adapt to effectively work with these tools. The source document defines AI fluency as the ability to work with AI systems in ways that are effective, efficient, ethical, and safe. Interacting with AI requires a formal framework. This isn't just a casual chat anymore. If we want professional, high-level results, we need a highly structured approach.
And that structured approach is built entirely on these 4 Ds. First up, delegation. This is task delegation. Carefully choosing exactly what the human does versus what the AI does, so you're playing to the strengths of both. Second is description. This means clearly defining the outputs, processes, and behaviors you expect from the AI. Third is discernment, specifically process discernment. You have to critically evaluate the AI's outputs, hunting for any logical errors or lapses in reasoning. Like, if the AI builds a financial model, discernment is stepping in to double-check that math before you present it to a client. And finally, diligence. This means transparency diligence, being totally honest about the AI's role in your work and vouching for the final product. If you submit code that an AI wrote, diligence is taking full 100% ownership of its functionality and security, just as if you typed every line yourself.
Okay, let's dive into Section 3, Mastering Prompt Engineering.
Now we're getting into the practical application of the description phase we just talked about. This is all about exactly how we structure our communication with the AI. So let's compare standard prompting with advanced techniques. Standard prompting is just basic, broad instructions. Honestly, it's kind of like telling an intern to just go fix the problem. But advanced techniques, like chain of thought and few-shot learning, these completely change the game. Chain of thought is when you explicitly ask the AI to break down its steps and show you its logic before it gives a final answer. This forces the model to actually deliberate, which drastically reduces errors. Few-shot learning is when you provide specific input-output examples directly in your prompt. By giving the AI an exact template to follow, showing it exactly what success looks like, you dramatically improve the quality of your results.
And that advanced structuring naturally leads us right into persona definition. Take this brilliant example. Explain this like Richard Feynman would. By specifying a certain character or expertise level or tone, you're applying strict output constraints. It fundamentally shifts the AI's behavior and ensures you get the exact format you need. Instead of getting some generic, boring textbook copy, setting a persona acts like a lens, focusing the AI's vast knowledge through a highly specific filter. It is such a simple trick, but it gives you massive leverage.
Which perfectly sets up Section 4, the 3 interaction modes. Let's zoom out for a second and look at the macro-level evolution of human AI workflows, because this really builds to our climax. Step 1 is automation. This is where the AI simply executes your exact specific instructions. Step 2 is augmentation, where you and the AI are collaborating as iterative thinking partners, bouncing ideas back and forth. But Step 3, the absolute peak, is agency. This is where the AI works independently on your behalf based on behavior you configured. It's a huge trade-off. You give up microcontrol over little tasks, but in return, you get massive macro power. It allows the AI to tackle complex, multi-step goals over hours or even days, entirely on its own, freeing you up to focus purely on high-level strategy.
And finally, Section 5, Claude Code Agency in Action.
Okay, here is the payoff I promised you at the start. Meet Claude Code. This is a true agentic coding tool that can literally read your entire codebase, edit files, and run commands. Remember those concepts we went over earlier, like context windows and chain of thought? Well, Claude Code leverages massive context windows to understand your whole project's architecture at once, not just a single file in isolation. It uses deep reasoning to write code, test it, and execute it right in your terminal. It isn't just throwing you little snippets and waiting for you to copy and paste them. It is truly taking agency over complex development tasks, iterating on its own errors, and actively building solutions for you.
Just look at how incredibly versatile an agentic workflow can be. Say you want to continue a coding session from your phone while you're commuting. Use the remote control option. Need to route bug reports directly into your workflow? Just integrate it with Slack. Want to completely automate your pull request reviews? Hook it up to GitHub Actions. Need to debug a live web app? Connect it straight to Chrome. Claude Code seamlessly integrates into almost every single facet of a developer's daily workflow. It stops being just a tool and really starts acting as an independent, highly capable team member.
So I'll leave you with this one question. Are you ready to move from automation to agency? We've learned the language, we've walked through the fluency framework, we've optimized our prompts, and we've finally seen what true agentic tools look like in the real world. Because the future of work isn't just about chatting with an AI, it's about configuring AI to work independently for you. I really hope this explainer has given you the foundational cheat sheet you need to start implementing these agentic workflows today. Thanks so much for exploring this with me, and keep building.